Unit 2, Set Theory and Logic. For the first lesson, we are going to look at statements and using the connecting words and, or, and not. In mathematics, we deal with statements. A statement is a sentence that has a truth value. It is either true or false. A sentence that may be judged true by one person and false by another is not considered a statement. This would be an opinion. Let's consider the following. The city of Vancouver is in the province of British Columbia. This statement is true. It is a fact. The city of Vancouver is on the planet Mars. This is a statement, but the statement is false. Vancouver is the best place in the world to live. This is not a statement. Some people would agree, some people would disagree. It is an opinion. How do you get to Vancouver? Well, this is not a statement either, because this is a question. Example 1. Determine whether each of the following is a statement. For each statement, list its truth value, that is, whether it's true or false. Number 1. The number 4 is a prime number. Now just recall that a prime number is a number that is only divisible by 1 in itself. For example, 7 is prime because it is divisible only by 1 and 7. In this case, 4 is not a prime number because it is also divisible by 2. Therefore, this is a statement, but the statement is false. Number 2. Driving in a car is the best mode of transportation. Some may agree, some may disagree. This is not a statement, but an opinion. Number 3. If you double an odd integer, then you get an even integer. Just remember that an integer is a counting number, but we also consider the positives and negatives. So it's -5, -3, 0, 4, 7. These are the integers. Let's try 3. 3 is odd. If we double it, we get 6. 6 is even. Try another. 23 is odd. If we double it, we get 46, and that is even as well. Yes, this will always work, so this is a statement, and it is true. The negation of a statement is the exact opposite of the statement. The word not is often used to form the negation of a statement. For instance, one way to write the negation of the statement, the city of Vancouver is in the province of Alberta, is to write, the city of Vancouver is not in the province of Alberta. Note that the original statement is false while the negation is true. In every case where the original statement is true, the negation will be false. Similarly, in every case where the original statement is false, the negation will be true. It would not be correct to say that the negation of the above statement is a statement like, the city of Vancouver is in the province of Saskatchewan. Both this statement and the original statement are false. A negation must also have the opposite truth value to the original statement. Example 2. A student made the following false statement. All triangles are isosceles. Which of the following statements below is the negation of the above statement? A. All triangles are not isosceles. B. Not all triangles are isosceles. C. All triangles are scalene or equilateral. We do want to use the word not, so we can rule out C, and A is the better of these two choices. All triangles are not isosceles. Example 3. Write the negation of the following statements. Number 1. It is 20 degrees Celsius outside. We just use the word not, so it would be, it is not 20 degrees Celsius outside. Number 2, it is not Saturday today. Well, we can see that it's already got the word not in it, so now we just remove it. So the negation would be, it is Saturday today. Compound statements. A compound statement is a statement formed by combining two or more statements. The words and or are often used to form compound statements. For example, it is 20 degrees Celsius outside and it is not Saturday today. Or possibly, it is 20 degrees Celsius outside or it is not Saturday today. These are both compound statements. Forming a compound statement using the word and. The conjunction of two statements can be formed by using the word and. A conjunction is true only if both of the original statements are true, and it is false otherwise. The conjunction of the two statements, blue is a color, with ice as a solid, would be the statement, blue is a color and ice is a solid. It is true because both original statements are true. The conjunction of wet is a color and ice is a solid would be the statement, wet is a color and ice is a solid. It is false because one of the original statements is false. The conjunction of wet is a color and ice is a liquid would be the statement, wet is a color and ice is a liquid. This would be false because at least one of the original statements is false, and in this case, both are false. Forming a compound statement using the word or. The disjunction of two statements is formed by placing the word or between them. A disjunction is only false if both statements are false. A disjunction is true if any of the following happens. The first statement is true, the second statement is true, or both statements are true. Consider the following statement. I've enrolled a pair of dice, and the sum of the two numbers was an odd number or a prime number. This would mean that the sum was an odd number, or it was a prime number, or it was an odd and a prime number. This is an example of the inclusive use of the word or in mathematics. Okay, let's try an example. Example 4. Consider the natural numbers x that are less than or equal to 15. So these would be all the counting numbers starting with 1 and going up to 15. List the numbers that satisfy each of the following conditions. A. X is odd. We just need to list all the odd numbers between 1 and 15. 1, 3, 5, 7, 9, 11, 13, and 15. B. X is prime. Recall that prime numbers are the numbers that are only divisible by 1 and itself. 1 is not considered a prime number, so we would start with 2. 2, in fact, is the only even number that is prime. Then we would have 2, 3, 5, 7, 11, and 13. C. X is odd and X is prime. So recalling that 2 is the only even prime number, it would be the remaining numbers just minus the 2. So we would have 3, 5, 7, 11, and 13. For D, where we have odd or prime, we're including all the odd numbers and all the prime numbers. So basically we have here all the odd numbers, and we would also include 2 because even though 2 is not odd, it is prime. E. X is a factor of 3, 5, or 7. So a factor is a number that will divide into one of those three numbers. So 1 divides into all of them, 3 divides into 3, 5 goes into 5, and 7 goes into 7. For F, however, we want a factor of 3 and 5 and 7, and the number 1 is the only one that will divide into all three. For G, X is a multiple of 3 or 5 or 7. These are all the numbers that are divisible by one of those three numbers. So we could list them out as 3, 5, 6, 7, 9, 10, 12, 14, and 15. For H, X is a multiple of 3 and 5 and 7. So we are looking for a number in which 3 goes into, 5 goes into, and 7 goes into. Well, none of the numbers less than 15 will work for this. So in fact, this is an empty set. And we can either state empty set, we can use set notation, which would be 2 curly brackets, but nothing in between, or we can use the empty set sign, which we will see again later on. For this last part, I just want to introduce Venn diagrams. We'll be looking at these in more detail later. The relationships between two or more sets can be illustrated visually in a Venn diagram. We start with a rectangle that contains the universal set, which is all possible elements. Then we use circles to represent subsets within the universal set. These may overlap, or they may be disjoint. The following examples show the universal set with two subsets, A and B. In the first case, we have set A and set B, so it's only those that are in both sets. Then we have in set A or in set B, so it would have all the elements in A and the ones in set B all together. And in the third example, set A and set B are disjoint. There are no common elements.